Alright, what's up everybody, Mr. Mira here, and today's video is actually going to be the continuation of strings, and more specifically, we're going to be looking at what does the immutability of the string class give us. Calling strings immutable objects, calling the string class an immutable class. What does all that mean? How does all that work? We're going to see it off on the whiteboard, we're going to see it off in code, and it will be a shorter video in the sense that instead of one 15-minute video from last time, we have two 7 to 8 minute videos here. So we're going to jump right into it. It's going to pick up exactly where the last video ended, so there won't be a searching for the class, finding the right class, and things like that. We're going to jump right in to IntelliJ, to the whiteboard, and get started. So with our whiteboard, let's correct some things here. Let's go in and let's erase memory location real quick, because we'll be redrawing that. And let's go in here and let's pick a different color. So I have string title, and title's Moana right now. And let's say, oh man, I wanted to actually have it be a capital M, but I don't want to go back up in my code and write that. So what I'm going to do is I'm going to update title. And you might just be asking yourself, well, you just said that strings can't get changed. They can't be updated. What are you doing here? And I'm saying title is now equal to Moana with a capital M. And that code's going to compile, that code's going to run. If I were to print this out, it would print out Moana with a capital M. But I didn't just change the string. Well, you might be thinking right now, you're crazy. You did change the string, and I see it changed on the screen right there. And you just said that it would actually run and compile and everything. But what's happening in memory is what we need to care about when I say that strings cannot be changed because of what they're doing in memory. So what is happening here is we originally had title, and title was pointing over here to this variable, and it was called Moana with a lowercase m. But then the next line of code ran. And when the next line of code runs, what it actually does is it now points to a completely different memory location that has Moana in it with a uppercase M. And what happens to this lowercase m version, if nothing else is referring to it, if no other variables or objects are pointing to it, it actually gets destroyed by the Java garbage collector. It gets taken away, it gets removed, its memory location gets cleared up for future use. So I didn't actually change the string. What I did was I created a brand new string. I created a brand new reference in memory somewhere else. It went to a different memory location, and it said, title, you are now pointing over to this memory location. So I didn't change its value at the original. That's what immutable means. I can update, but I'm actually creating a brand new string according to the memory that is being run by Java Virtual Machine that is happening in the program. It's a brand new memory location. Let's try to end this by showing this off in code, and hopefully we can get it to work. Sometimes it's a little touchy if we try to do it in code only. So let's go back here, and we're going to delete this, and I'm going to say string name equals, and we're going to say Cat Stevens. So Cat Stevens gets set up, and then we're going to we'll print out Cat Stevens. We'll do a system.out.println, and we'll say name, and let's do another string. Let's do string new name is equal to name. So now these two, let's put some debug statements on, and we'll try to make this quick. And these two are going to actually be at the same memory location. What's up everybody, editing Mr. Mira here, and I actually wanted to pause the video right here because I wanted to also show off, I didn't think of it to show it off in the video at the time. Setting new name equal to name here is fine, it shows off the same concept, but I want to show off if I set new name equal to Cat Stevens. I want to show here that they're actually at the same memory location as well, even though they have the same value in it. It's not two different memory locations. So if I run the code, and you're about to see me run the code when the video cuts back in, doing this debug style to kind of show off the locations. So I have my first Cat Stevens of name. It's at location 804. And then when I get this Cat Stevens of new name, it's at location 804 as well. So even though new name no longer equals the variable name, and it might make sense that they would be at the same memory location if I say new name equals name, I wanted to show off that even if new name equals just the same letters and words, capitalization and everything as another string, it actually exists at the same memory location as well. So that's why strings, they will all reference the same location if they are the same word, capitalization, and everything like that. If a version exists somewhere in the string pool, that is where it will get referred to. There's a lot more going on here with the string pool and heap memory and how all that works, and we will look at that in a later video in a different series when we dive deeper into Java. That is beyond the basics at this point. At this point, what we should know is that strings will always refer to the same location if it already exists in memory. We'll get back to the video where I have this left as name, and it shows off a similar thing here. They're both at the location, they're both at the same location, and how things work. So let's jump back into the video and finish off everything that we need to. But they're both referring to the same memory location. They're both referring to Cat Stevens at the same memory location. Remember, reference types, I have a separate area that's holding the actual value of Cat Stevens. So more than one thing can be pointing to that memory location. So that's kind of cool there. So I have Cat Stevens and they're both getting printed like that. Now, what if I were to change and I wanted to say new name? You know what? I want to say Cat Stevens with a lowercase c. We'll do the last name spelt exactly the same way. So all I'm changing is the first letter. I'm going from an uppercase C to a lowercase c. And this is where having an immutable object, an immutable class, comes in handy. Because now if I were to just do a print here so we can get our breakpoints to run without stopping the code, and let's rerun this. So we're going to see something happen here. So we're going to see Cat Stevens and we see 804, and then we see Cat Stevens and we see 804. But now I'm about to jump down and make new name Cat Stevens with a lowercase c. So when I move to the next line, Cat Stevens is going to have a lowercase c, and I want you to watch the part that's highlighted right now. So it's at 804. I go to new name and it becomes 818. So Cat Stevens now has a lowercase c. So I can update, I can change one of my variables without impacting all the other objects that are pointing to that same memory location, because I'm immutable and I'm actually making a new memory location. And that's kind of a lot to take in. And I understand that because it is a lot to take in. It's a difficult concept to grasp onto, this idea of immutability where things cannot be changed. They get updated, they create brand new locations. So hopefully this kind of shows it off, or the drawings kind of showed it off. But just know that if I have multiple strings, they can all be referring to the same memory location. But if I change one of those, I actually create a brand new string that gets referred to. All the other ones still point to the old memory location. And that's only for strings. That's only for immutable objects. As we start seeing other reference types later in the year, it doesn't always work that way. So just keep that in mind. This is only for strings. This is only for immutable objects. And there's actually more happening behind the scenes here in terms of the string pool that gets created in Java and the heap memory that gets created in Java. We're not going to dive into that in these videos. We're not going to dive into that here. That's more of an advanced topic that we will look at maybe in a different series or something like that if people want it. But just keep in mind that strings kind of play by their own rules, being immutable and being reference types that are immutable. So that's an important thing to remember here. Next video, I think we're going to step back from strings for a second, start talking about methods and what methods are and how we get to methods. And then we'll jump back into strings when we have this basic understanding of methods, and we'll start talking about string methods in a couple videos. But until then, everybody, have a week.